Okay, so I don't actually have much time today, so I'd like to get. Maybe we'll do this one and then we'll evaluate. Oh no, let's see. Maybe we'll do the first, or maybe I'll just go for like 5 minutes. Who knows? Let's see. So we're on. Okay. Okay, one thing about this is I feel like I have just kind of put everything here, but over the next ones I think I'll be more focused. Okay, so, okay, I guess we'll just do this one first, and then we'll go from there. Okay, a lower bound is a function with a lower bound is one in which it doesn't go beyond some specified value. Opposite of lower bound. The antiderivative for sine of x, I believe, is cosine. What is the difference between infinite discontinuity and jump discontinuity? An infinite discontinuity is one that approaches infinity. Yeah, that like asymptotes to infinity. A jump discontinuity is when you have just a value that doesn't exist there. Okay. Okay. Yeah, okay. This is when you have a limit, or sorry, it's undefined. Actually, no, you have a limit, but they differ. Exist, but they're not equal. I see. Okay, so that was incorrect earlier. Exist, but they're not equal. Okay. Dun 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 dun. I know I didn't do my on key today either. Work has been nuts. Okay. Yeah, maybe we'll hit. Let's see. So we're 2, 3, 1. Okay, so I think we'll just start with 3. Oh, I should probably zoom in for you guys. Okay, state the domain and range for a function. Okay, so it seems to me that the domain... okay, so a domain is the set of x values, and the range, I believe, is the set of y values that emerge from that. For the domain, I don't think it's likely the case that we ever have... or let's see, I guess... It seems to me that in almost all cases, the domain should be negative infinity to positive infinity. The one case where this may be not true is that, say we have a given x value, which is undefined, or rather we substitute it into this function, and we get undefined. If that's the case, I would assume that we still have that value in the x domain. It just doesn't exist in the range, though I'm not sure that it's the case. And then with this one, I'm not entirely sure the method for going about doing this thing. I don't know how you would yeah, I'm not sure. So I can have an intuition. Like I think that for the domain here, that we're negative to positive infinity, and for the range it seems like the same. That's kind of where I'm at. So who knows? But that's my intuition. But like previous problems, like my intuition's great, but I need to be able to prove it, or it's like I don't know, it's sort of worthless in terms of like describing the math that's going on here. So yeah, so I'm not sure how if it's something you just see or notice, or how it could be made explicit. I'm going to think just a little bit more to see if I could identify something. But I guess this practice is good generally. Notice how I'm generating hypotheses about how this might be the case. And so I can be proven wrong and tested. And when you test yourself, even for things like what you don't know yet, if you generate a hypothesis and then test the hypothesis, you'll remember it more because you're generating a possible conception for what might be the case for this thing. And then additionally, not only are you generating this hypothesis, but it's also you're also generating it, or you're generating the thing that you're wanting to know. So for the generation effect, which is this idea that if you put effort into creating something or generating or any sort of generative or creative effect, and I'm going to be more specific about what that is entirely, that you'll remember it more. And so a example of this was, okay, they had, students have 30 seconds or something for a list of words. And some students were given the entire word. And then some students had most of the word, but there were blank spaces in the word, and they had to come up with the remaining letters and then memorize the word, right? And so you'd think, wow, I mean, like the students that had the holes in their words, it seems like it would be the case that they wouldn't do as well, right? Because they're doing sort of extra effort outside of just memorizing, right? If I had this finite pool of effort and I spend some of it on coming up with the word and then spend effort on memorizing it, like you could see that we have, maybe some sort of model or mechanism for why we should perform less well. But it's actually the opposite case, where those that generated or had to find out the letters, that they were able to remember the words more. And that's to say that, we can exert some effort in this in a particular area, and that effort's good, right? But more effective than that is generating the effort towards the end we are wanting to achieve. So, in this case, like, imagine, okay. So imagine so imagine when I'm trying to learn about what a domain is, I do some generation, but it's for a completely unrelated thing. So say I'd like to, I generate a story about domains, like you could even do like website domains, right? And so I'm generating a story about domains, but it's not really tied. Like obviously they're using the same word, so there's some like conceptual similarity there, such that they use the same word, they identified it as the same thing. But a domain in a mathematical sense is different than in like a technology, like software engineering, side, right? And so I could like generate or use some effort to make up a story about how domain is used in a different area, and like maybe there's somewhat similarity there in helping me remember what this domain is, right? But if I instead exert the effort towards the end I'm wanting to achieve, then I will reap far more benefit than just some random effort. Or say, so you could think about another situation where maybe we draw a picture of, this would be, I don't know. Anyway, so this is to say that when you're exerting effort, you want to do it in the way that's reasonable, and that you're in a way where you're getting the outcome that you're wanting to achieve. I think I have a better idea. So, say I'm wanting to learn the particular concepts in a book, and so we'll say I'll give two approaches. So one approach is that I exert mental effort in trying to understand the concepts themselves. So like I just did, I tried to make a hypothesis about what or how we find the domain and range. And then I tried to test that hypothesis, right? We'll say in another, or like a different way I could do it, instead of going by the concept level, I instead think about the set of things that I know. And so I'm reading through like a textbook, right? And I think about the things that I've learned so far in this chapter and try to predict out what it'll be that I'll learn later in this chapter. So I'm also exerting mental effort there. And it certainly will help me remember, right? And both of these are good, right? But I'd probably say that, the conceptual one would help you more with the concepts, right? And the predictive one, where I'm trying to figure out what will come next in the chapter, will likely help with the concepts, but it's more going to help in a sort of... it's going to help build a representation of the sort of knowledge map in this particular area. So if I'm reading through a chapter for something and I'm trying to predict what the author is going to describe next, then I need to understand what is the use of the concepts in this chapter so far, and what is missing in my like explanation or in my learning to this point. Like what content is logically follows this, but is presently not here, right? So I guess this is all to say that when you exert mental effort, exerting it in the correct area will be of more benefit than like exerting it just generally, right? Like another thing. Okay, I just thought of a better example. So say I have to create a story where it's merely the case that I need to use the word domain 30 times, right? So it's pretty arbitrary. And for this, say I'm not even trying to use it in the context that I'm trying to learn it. So creating a story about the word domain will certainly help me remember, like maybe domain more, right? The word itself. But if this is the first time that I've interacted with it, it's not likely the case that I'll remember what a domain is, given like this random story where I'm using the name or the word domain 30 times. And yes, I'm exerting cognitive effort, but and exerting cognitive effort is better than not exerting cognitive effort, right? But it's certainly the case that it would be more effective if it was more focused towards the end that I'm wanting to achieve for that thing. So if I want to understand and know something, if I exert effort towards understanding, and this can mean deliberately making something difficult when you're going into it, and not like deliberately like hamstringing like yourself, but if I could have said immediately after I saw this question, I don't know how to. Oh, let's see. Let's turn back. So I could have said immediately after I saw this question, I don't know how to. Or after I saw this question here, I don't know how to evaluate this. Well, we'll zoom in. I could have immediately said, after I saw this question, I don't know how to evaluate this. And then I could have gone, how to find the domain and range of a function. And it will tell me, right? And so, but I would have missed out on exerting cognitive effort. Because now that I've sort of proposed a way that I might accomplish this, and one caveat with the domain where I said, okay, I'm not sure if I have an X value that is undefined or it returns an undefined value or a value that doesn't exist, or I guess a non-value is probably the more mathematically precise way to say. I don't know if X still is in that domain, right? So I'm not sure if or what causes a value to be removed from a domain. It's clear what causes a value to be removed from the range, right? If it's just not represented in the function's output, then yes, like you're just not there, right? And this can be like any number of things. Like if you have a discontinuity, if you have upper or lower bounds, your range is going to be constrained, for the function. So let's see what we have. To find the domain and range of the function, first determine the possible input values for the x function, which constitute the domain. Then identify the set of all possible output values generated by the function, which defines the range. Okay. Could you walk through how I might find a domain and range of a function? ? I am wanting to understand what things might exclude an x value from being included in the domain. I do understand what causes a y value to be excluded. For example, if there's a discontinuity or if I have upper or lower bounds for a function, it makes sense that a particular y value is excluded, period. Could you also go about describing sort of an approach for evaluating the domains and ranges for a function? Okay. I think that's reasonable. You need to determine all possible input values, x values that the function can accept, the domain, and the possible output values y that can produce that the function can produce. Below, I'll explain the process systematically with a focus on what might exclude an x value from the domain and provide a general approach for evaluating both the domain and range, including examples to illustrate. If the domain of a function is the set of all x values for which the function is defined. Okay, that's it right there. So if I have a value that is undefined, then it doesn't exist in the domain. To find the domain, yep, okay. Certain mathematical operations, operations or properties of a function can prevent specific x values from being valid inputs. Here's the primary reasons an x value might be excluded: division by 0, even roots for negative numbers, logarithms of non-positive numbers, trigonometric restrictions, piecewise function restrictions, general approach. Okay, a general approach to finding the domain: identify the function type, check for undefined points, combine restrictions. Express in interval notation. Consider the context. Finding the range. The range is okay. The general approach for finding the range: analyze the function's behavior, use the domain. Find critical points, check the limit's boundaries, test for attainability, consider discontinuities or bounds, express in interval notation. Okay. Okay, so I feel good in like the general case about this. So it is the one thing I did learn is that what excludes an x value, or I guess an input value for the domain would be if it's, what excludes a value from the domain is if it's not defined at that given point in a function. So if I have f of x equals 1 over x, yes. If I have f of x equals 1 over x, then 0 would be undefined because I'd be dividing by 0. Okay. I feel pretty good about that. Okay. I think we'll actually have to stop there for tonight. Yeah, but this is good. I think we had a good little thing. I'm actually not super concerned about on the one hand, I'm interested in taking however long it takes for calculus, right? And being that I'm constraining myself to 3 hours a week, and often not even 3 hours a week. Obviously it'll go slowly. But as long as I'm making little chips of progress, I think I'm okay with things. Yeah. So this is my last one for this week. So I'll be here next week. So see you guys later.